Hi Achievers, Achieve Maths. We're looking today at the Pearson Edexcel GCSE Mathematics Paper 1, which is a non-calculator foundation tier. So without further ado, let me work through the paper with you. Number 1. Work out the value of 2 to the power of 4. Well, 2 with a little 4 means how many times you have to times 2 by itself. So the number we're timesing by itself is 2, and the number of times we're doing it is 4. So you'd write 2 times 2 times 2 times 2. So like I said, the big number is the number that you're multiplying, and 4 is how many times you're doing it. 1, 2, 3, 4. 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So your final answer, 16. You can see why this notation is very useful, because what if you had 3 to the power of 11? You don't want to sit there writing 3 times 3 times 3 11 times, do you? It's boring. Moving on. Question 2. 7.26451 corrected to 3 decimal places. So we're going to round it. Now we count 3 numbers after the decimal place. 1, 2, 3, and that's where our number is going to stop. Now to see whether we round up or keep it the same, the 4, we look at the next number. Now, if you think of your number line, starting from 0 up to 10, 5 is bang in the middle. So we have to have a rule. And the rule says, if you're in the middle, round it up. And if you're below here, round it down. So like we just said, 5 means we're going to round up, and we're going to round the 4 up to a 5. 7.265 is your answer. Moving on. 3a. Simplify 7 times e times f times 8. Let me use a highlighter now. I will highlight in yellow our normal numbers. And let's highlight in green our letters. Now we don't know what E and F are standing for at the minute, but we know how to do 7 times 8. Okay, 7 lots of 8. Well, 5 lots of 7 is 35. 3 lots of 7 is 21. Add them together, you get 56. Or you might be good at mental maths and already know that. Well done if you do. Now, in algebra, which is what this is, using letters, we don't need to write the little cross to mean multiply. If you've got, say, 7 times e, everyone knows what you mean if you just write 7e. They know it means multiply. So we're going to leave out the multiplies. Instead of 7 times 8, we're putting our 56. And the e and the f we're going to write without the multiply signs. So our final answer is 56 e f. Moving on. Part B. Solve x over 5 equals 2.5. Now, this is an equation that we need to solve. We need to get x on its own when you see an equation. So our aim is to get x equals, and it's already given you that clue. Now, if you've got x and it's being divided by 5, how do you get it on its own? Well, what's the opposite of divide by 5? It's times by 5. Okay? So if we're dividing a number by 5 and then timesing it by 5, we're going to get x on its own. I'll give you an example. Imagine if you've got 10 and you had 10 divided by 2. Well, 10 divided by 2 is 5. Now what if you did 10 divided by 2 times by 2? Well, 10 divided by 2 gives you the 5, and then times it by 2 you get 10. Now a quick way that people who are very fast at maths do is they say, right, we're dividing by 2, times them by 2, cross them out. But anyway, that's another story. Let's get rid of that. We know from this work down here that we want to do a times by 5. Now these sides of the equation are equal. If we just times 1 by 5, they're not going to be equal anymore. Imagine that you've got balanced scales. Now you guys are going to be probably younger than me, so you might not know about these scales. Imagine that you've got things on each side that are balanced, okay? Then the scales are flat. As soon as you put more on one side, then it's heavier, so one side will go down. That's like an equation. You're equal if you're the same on both sides, because then you've got a straight line. Anyway, let's get back to business. We want to times the equation by 5. To be fair, we need to do it to both sides. So let's do times 5 times 5. Now we've been talking for ages that x divided by 5 times 5 again gives you x. So we know what we've got on the left hand side. 2.5 times 5 is a bit more tricky. Okay, let's write that separately. 2.5 times 5. Now, there's many ways to do this. I am going to show you the fractions way. Okay, 2.5 is like having 2 wholes and an extra half. That's 2.5. Okay, so how many halves have we got? Sorry, that's not a very straight half, but you know what I mean, don't you? Okay, more like that. So we've got 1, 2, 3, 4, 5 halves. Okay, so that's 5 halves. 5 over 2. Times by 5. Well, 5 times 5 is 25, and you've still got the divide by 2. Any questions on this? Give me a comment in the video. I'll be sure to listen to what you say and try and hook you up. Okay, so 25 over 2 can be left like that, but it can be written as a mixed number, which means a whole big number and a fraction. 25 over 2. Now, some of you might already know it's 12.5. Well, why is that? Because 2 goes into 25 12 times with 1 left over. 12.5. Moving on. Write 4 over 5 as a percentage. Now, percent means what have you got out of 100? You might be familiar with this from test scores. Everybody wants to know the percent of something. Now 4 over 5 doesn't tell you straight away what percent it is. We have to figure it out. And the way we're going to do that is convert 4 over 5 to something out of 100. And we want to figure out what this missing number is. So, what do we times 5 by to get to 100? It's 20. We have to do the same to the top as the bottom. In maths, a lot of the time, it's about keeping things fair. like when we were solving the equation. 4 times 20 is 80. So that means it's 80 out of 100. Now because we all know what percent means out of 100, we can just put the number, the top number. There's our answer, 80%. Moving on. Percent of 70. Now we've just been talking a bit about percents. 60%, you're talking about 60 out of 100. But we're not talking about out of 100 here. We're talking about out of 70. So the question is saying, what is the same out of 70 as 60 is out of 100? Now this is going to get a bit tricky, because we have to figure out how to go from 100 to 70 so that we can do the same at the top. So how do you go? You can use times and divide from 100 to 70. The answer is you divide by 10 and then you times by 7. Let's just check this works. 100 divided by 10 equals 10. 10 times by 7 equals 70. Cool. So let's do the same to the top to get our answer. Now, you have to divide by 10 first. So 60 divided by 10 equals 6. Then you have to times by 7. So 6 times by 7. Remember we said before, 7 times 5 is 35. Add on another 7, you've got 42. If you know your times tables, this paper is going to be much easier. So get learning them. Sammy spins a fair 4-sided spinner. Here's a picture of a spinner, you see. A, B, B, and C are our options on the spinner. On the probability scale, mark across the probability that the spinner will land on B. Let's think about our options. How many options are there? 1, 2, 3, 4 options. How many of those options are B? 1, 2. So the probability is 2 out of 4. But look at our scale. It's only got out of 2. Well, 2 out of 4, guys, is the same as 1 out of 2. And I've been showing you this all through the video. Divide by 2, divide by 2, you see? Keep it fair. Keep doing things the same on the top and the bottom. And a little diagram to show you this. That's half of a circle, a cake, whatever you want to think of. Okay, let's shade in half. Well, what if we weren't cut in half? What if we were cutting quarters? You've got 2 of them, you see? 2 out of 4 is the same as 1 out of 2. On the probability scale, mark with a cross. The probability, it will land on B. Let's chuck the cross on there. Part 2. On the probability scale, mark with a cross the probability that the spinner will land on F. I don't know about you guys, but I can't see an F on that spinner. The only things you can get are A, B and C. Unless someone comes along and draws an F on, you can't get an F. So on that spinner, it can't happen. The probability is 0. Moving on. Fahima buys 2 packets of bread rolls costing £1.50 each packet, 1 bottle of ketchup costing £1.60, 3 packets of sausages. Wonder if she's going to have a barbecue. Fahima pays with a £10 note. She gets 30p change. Fahima works out that 1 packet of sausages costs £2.30. Is Fahima right? You must show how you get your answer. Let's see how many marks are available here. It's 3 markers. Right, 2 packets of bread rolls. Now you might not do this in the exam, but I'm walking you through it. So I'm going to show you what a packet of bread rolls might be like. Something like that. And we've got 2 packs. And they cost £1.50. We've got 1 bottle of ketchup that's costing us £1.60. Imagine if you're in the shop buying all this. And we've got 3 packets of sausages. Now let's not do a masterpiece, let's just get a quick couple of sausages drawn on. 1 pack, 2 packs, whatever, 3 packs. And we don't know how much she's paid for them yet. But she paid with a £10 note and she got 30p change. Now let's use algebra. We don't put question marks around in maths, we put a letter instead, and the unknown letter is usually x. So x just means we're not sure what it is yet. Okay? So £1.50 plus £1.60 plus x, but if 1 packet of sausages was x, we've got 1, 2, 3. So 3x plus 3x, and that gives us how much she paid. Let's figure out quickly how much she paid. She paid with a £10 note and got 30p change. Now £10 take away 30p is £9.70. So that's how much all this stuff cost her. Let's try and do some maths now, figure this out. £1.50 plus £1.60 is £3.10. £3.10 plus 3 lots of x equals £9.70. Now we want to solve and find out what x is. Okay, so we need to get x on its own. Our aim is to get x equals. So we want to get rid of this guy first, the £3.10. So let's take away £3.10 from each side. Imagine it with real money. You had £9.70, you take off £3.10, what have you got? Well, your 70p take away your 10p gives you 60p. Your £9 take away your £3 gives you 6 quid. So 3 lots of x gives you £6.60. So we want 1 lot of x. Okay, to get x on its own we have to do the opposite. Remember what we said? Number next to a letter means there's an invisible times. We need to reverse that. Let's divide both sides by 3. 660 pence, or £6.60, divide it by 3. Pretend you've got yourself and 2 mates. How much are you going to get each? £2.20. So, is she right? That's the question. She said £2.30. So she said £2.30. So she is wrong. Afraid to say it, Fahima. You're wrong, girl. Moving on. Question 8. 5/8 times by 3/4. Times is the easiest stuff to do with fractions. Let's times the top. 5 times 3, 15. And times the bottom. 8 times 4 Well, to times by 4, I'll show you a little trick. Times it by 2, times it by 2. That's the same as times by 4. Okay, remember that one. So, 8 times 2 is 16, times by 2 again, 32. That's your answer, 15 over 32. Work out 2 over 3 minus a quarter. This one's a bit trickier, guys. Plus or minus are the ones to look out for. They're hard. I teach a couple of methods for this. One of them is called the smiley face method. All you have to do is draw a smiley face onto your work. Now it's one of those smiley faces where the eyes are like across, you know, those ones. Maybe their eyes are here or something, I don't know. That's the face you have to draw to get this right. So, along each line we're going to times, and our answer is going to go into a new fraction. You'll see. 2 times 4, that gives us 8. 3 times 1, that gives us 3. 3 times 4, that gives us 12. And now let's remember what the sum is we're doing. It's a minus. It's a take away. So that means that you have to chuck in a takeaway here. Okay? 8 minus 3 is 5. And 12 is on its own. 5 over 12. Job done. 2 marks in the bag. Moving on. Question 9. Sean works for a company. His normal rate of pay is £12 per hour. When Sean works more than 8 hours a day, he's paid overtime. This happens sometimes in life. You'll be glad to know. You get more money. He is paid overtime for each hour he works more than 8 hours. Sean's rate of overtime pay is 1 1/4 times his normal rate of pay per hour. On Monday, Sean worked for 8 hours. I'm sorry, I've misread that. Sean worked for 10 hours. Work out the total amount of money Sean earned on Monday. When you get a job, you might be interested in working out this type of thing. Okay, let's get down to business then. £12 per hour for the first 8 hours. Okay, so 8 times 12, more times tables. I'm not talking you through all of these now, we're on 96. So that's 8 hours down. He's worked for 10 hours in total, so that means he's done 10 minus 8 is 2 hours of overtime. Okay. Now this is tricky because we have to figure out how much he's getting paid for his overtime. It's 1 1/4 times his normal rate of pay. So he's got his normal rate, 12 quid. Then he's got a quarter more. Now a quarter of 12 is 3, because 3 plus 3 plus 3 is 12, okay? You see? Quarter, 1, 2, 3, 4 of them. That's one way to think about it. I'm showing you different ways in this video, you might have noticed. So, 12 at 3 means when he's getting overtime, he's bringing home 15 quid an hour. So for his last 2 hours, he gets 15 quid, which gives him 30. He gets all of this money, so we need to do 96 add 30, 6 add your 0 is 6, 9 add your 3 is 12, so 2 carry a 1, nothing else going on, 126 nicker in the bag. That's your answer. Not bad for a day's work, eh? Let's put it down there. Question 10. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. Give your answer in its simplest form. Okay, let's give it a go. 20 boxes of eggs. 6 eggs in each box. So imagine all the boxes. I'm not going to draw 20 out. Okay, imagine there's 20 of them. And you've got 6 eggs in each. You know how they're laid out. You might have seen them in a supermarket. So, it's 6 times 20. So 20 times 6. Now, when you're multiplying, we've seen that you can split things up. Like when I showed you, times by 4 is times 2 times 2. Times by 20 is times 2 times 10. Because you see, those together, multiplied, give you 20. So 6 times 2 is 12. 12 times 10, add a 0. 120. Now, write as a ratio the number of eggs in 2 boxes to the total number of eggs, and we need to simplify. The number that we've just worked out is the total number of eggs, 120. We actually want also the number of eggs in 2 boxes. So 1, 2. So that's 2 times 6. Okay, 2 times 6 is 12. So we want the ratio, which is just showing you how one number relates to another, of 12 to 120. And the way we write ratio is 2 dots to separate them. So 12 to 120. Now, can you see those numbers are very similar? We can simplify, like we've been doing with a lot of things, keeping it fair. These numbers can both be divided by 12. Okay, and if we do that, it will simplify. 12 divided by 12 is 1. 120 divided by 12 is 10. Again, times table practice, paying off a treat. Question 11. A sequence of patterns is made from circular tiles, as shown here, and square tiles, like this. Here are the first 3 patterns in the sequence. Pattern 1, pattern 2, pattern 3. Now this is testing our ability to notice how we're going from one to the other. Now can you see that in the middle, what we're doing is we're having these squares, and they're getting bigger each time, but staying as a square. So the first one is 1 across, then 2 across, then 3 across. Okay, and if you want to get really complicated, then they're square numbers. So look, 1 by 1, this square here, is just a bit of a dodgy square, but let's take that to the side. It's 1 by 1. So the area inside is 1. This one here, let's take it to the side. Again, that's 2 by 2. So 2 times 2 is 4. Can you see? 1, 2, 3, 4. So we're right. Next one. Sorry about this square, that's pretty dreadful. 3 by 3. So to get the area, we do 3 times 3 is 9. And you can check 1, 2, 3, 4, 5, 6, 7, 8, 9. So the next guy over here is going to be 4 by 4. 4 times 4 is 16. Now look what we're doing around the edge. we're adding on 1 for each side. Okay, now the number of sides here is 1, so it's that times 4. 1 times 4. Number of sides here is 2. Well, the number on each side is 2. So it's 2 times 4. 1, 2, 3, 4. Here, 3. And it's 1, 2, 3, 4 again. So 3 times 4. Now, if we put all of this together, what we'll actually be able to do is get a formula. Okay? But let's see what the question's asking us. How many square tiles are needed to make pattern number 6? Well, it's just going to be 6 by 6. 6 times 6 is 36. 2 marks. B. How many circular tiles are needed to make pattern number 20? So on pattern 1, there's 1 on each. Pattern 2, there's 2 on each. Pattern 3, 3 on each. Pattern 20, there's going to be 20 on each, and there's still going to be 4 of them. Okay, so we're going to do 20 times 4. 2 times 4 is 8, and you've got your 0. 80. Next one. Derek says, when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek right? You must give reasons for your answer. So odd numbers are 1, 3, 5, 7, etc., etc. Let's look back at our patterns. Odd number of square tiles. So here our pattern number is 1, and the number of square tiles is 1. Correct. Here, pattern number is 3, and the number of square tiles is 9, which is also odd. So he's right there. How about 5? Well, remember, it's going to be 5 times 5, 25. And they're both odd. 7 times 7, 49. Odd again. Now, we can't keep doing this forever. So what we need to do is think of a clever way to be able to show this without doing every single multiplication. So let's think instead about an odd number times another odd number. Now, any even number times by an odd or an even will always give you an even, and the only times that you get an odd in multiplication is going to be an odd times an odd. Okay, so an odd number times an odd number equals an odd number. So Derek is right, or is correct. There you go. Moving on. There are only 7 blue pens. Okay, let's do a very quick 1, 2, 3, 4, 5, 6, 7. 4 green pens. 1, 2, 3, 4. And 6 red pens in a box. 1, 2, 3, 4, 5, 6. And let's put them in a box. Okay, we've got our pens. 1 pen is taken at random from the box. Okay, so you're not looking at what colour it is, you're just going to randomly pick one out, mix them all together, pick one out. Write down the probability that the pen is blue. Okay, now look at the numbers and look at the diagram. There's more blue pens than not blue pens. Okay, there's more blue pens than greens, and there's more blue pens than reds. How many blue pens have we got? 7. Okay. And what's our total number of pens? It's 7, add 4, add 6, 17. So 7 out of 17 is your answer. The diagram shows a tree and a man. The man is of average height. The tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. Now, if you've measured yourself lately, you might know how tall you are in meters. It's useful to have a good idea of about how tall people are in meters. If you see a very tall person, they could be 2 meters. A shorter person could be down to 1.5 meters. We're going to say 1.75 meters as our estimate. You wouldn't have to say that exactly in your exam, but it would have to be somewhere between 1.5 meters to 2 meters. Find and estimate the real height in meters of the tree. So if we're saying this guy is 1.75, how many times does this guy fit into the tree? Okay, so there he is. So 1, 2, 3, 4, about 5. Okay, it's about 5, and it's just an estimate. That means that we don't have to be perfect, and because we estimated in part 1, it would have been fine to put even 1.8. okay, just less accurate. But let's keep working with 1.75. It would just make our multiplication a little bit trickier, because we've got to do 1.75 times by 5. 1, 2, 3, 4, 5. Okay, let's do another method to show you. 5 times 5 is 25, carry a 2. 5 times 7 is 35, carry a 3. You would be putting a 5 here, but we've got the 2, takes it up to 7. 5 times 1 is 5, plus your 3, 8.75 meters. Here's your answer. Moving on. Question 14. Year 9 students from Halley School were asked to choose one language to study. The table shows information about their choices. Draw an accurate pie chart to show this information. Okay. Well, we might need a protractor at this rate. Let's see how many students we've got in total. 56, add 40, add 24. Well, 24 add 56 is going to give you 80, because your 4 add your 6 is 10, and your 20 gives you 30, add your 50 gives you 80, add 40, 120. You can use that sign for total. How many degrees in a full circle? You need to learn 360 degrees. Okay, so the total degrees to get them to fit into the whole circle need to be 360. So, like before, we want to go from 120 to 360, and we can do that by timesing by 3. So, easy one first. 40 times 3 is 120. 24 times 3 is a bit trickier. It's only timesing by 3, so we could just do repeated addition 3 times. 4 add 4 add 4, 12. 2 add 2 add 2, 6, plus your 1 here, 72. 56 times by 3, let's do the same method. 6, 12, 18, carry 1. 5, 10, 15, you've got your 1 there as well, 168. Now, if we've done our maths correctly, these are the angles, by the way. Then these three numbers will give us 360 like we thought. So let's just be good students and do a test. 8 add 2 gives you 10. 6 add 2 is 8, plus your 7 is 15, plus your 1 is 16. 1 add 1 add 1, 360. So it's a nice little check that we've done. Now we're going to have to try out using our protractor. Right, so this is what you would do. You'd spin it round and see this cross here? That has to go right on the point. Now, our first angle to measure, doesn't matter which way around actually, so let's do our easiest one first, 120. You always have to start on 0, see this 0 here, and count around the edge. Say you went to this 120, you've gone wrong, because that means you started at 180 here. So around the edge, all the way to 120, and you'd put a mark at 120. Okay, now if we were doing this in real life, we'd then take this away, and you would get your next piece of equipment, which is a ruler, and you would draw a line. Oh, spin this guy around through those two. It's much easier to place your ruler in real life. You'd get your pencil and you'd rule the line there. Okay, now you could label it at this point if you wanted. Remember we did Spanish first, 120, and label that Spanish. Okay, next one, doesn't matter which way around, let's do 72. We need to line our protractor up with this centre again. Get that ruler out the way. And we need to do 72 degrees this time. Starting from your 0, 0, 10, 20, 30, 40, 50, 60, 70, 1, 2. Each little dot is 1 degree. Okay, so that's on your 72. Let's get our ruler back in action. Guys, I hope you can do this quicker than me in the exam. Okay, there we go. You'd be doing some pencil in the exam. Draw a line with our ruler, and this subject was 72 degrees for German. So let's label that one German. Okay. Now, if we've done this right, the remaining one will be French, and it will be 168 degrees. Now, if we're a really good student, we'll check that everything's okay. So let's get our protractor back in action. I'll show you measuring from the other way this time, just for a bit of variation. So remember, put it in the middle. And this time, don't start at 180, start at 0. So we're going to count around from 0 in the inside track, all the way around, 160, 5, 6, 7, 8, 168. Job is a good one. Okay, nice work. You get 3 marks for that because it takes up a bit of time. Year 9 students from Lowry School were asked to choose one language to study. This accurate pie chart shows information about their choices. Shamina says, the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Hale School. Right, I can see why she thought that, because let's have a look at the pie chart. You can see what's been going down on this pie chart. Let's try and take it onto the next page. Cool. So this one was hail, and the one underneath it is Lowry. So can we see why she thinks there's more for students at Lowry School than Hale? Okay, because the area for French is bigger. Just leave this guy here. So what we're talking about is this area for French is bigger than this area for French. But what do we not know? Well, the previous one, French, this meant 56 students. Okay, so think very carefully. Do we know how many students did French here? What if there were only 100 students in the school for Lowry? Well, what if there were only 10 Year 9 students in the school? Then this can't be more than 56. So she is not correct. More Year 9 students. So we can say we don't know how many students did French at Lowry. We only know the proportion. So she is wrong. Okay. Moving on. Here are a triangle and a rectangle. The area of a rectangle is 6 times the area of the triangle. Okay, work out the width of the rectangle. I like this question. Here's the width. This is what we want to figure out. Now, first things first, let's figure out the area of this triangle. Now, a rectangle would be very easy to figure out the area because we just do 9 times 8. And 9 times 8 is 72. But all we've got is actually half of that, because we cut it down the middle. Okay, half, half. And half of 72 is 36. Now, what you might have been taught at school is a half times the base times the height. So half times the base times the height. Half times 8 is 4. Times by 9 gives you the same thing. Okay. So, the area of a rectangle is 6 times the area of the triangle. So this is 6 times 36. So let's work it out down at the bottom. 36 times 6. Well, 6 times 6 is 36. And 6 times 3 is 18. So 18 plus your 3 gives you 21. So 216 is the area. So let's call this question mark. So something times by 16, base times height, gives you 216. And we have to work out what that something is. So this is really testing your number skills. We want to know how many times does 16 go into 36. Okay, not 36, sorry, 216. So we're going to need a bit of calculation space, and we're going to do 216 divided by 16.
what we're going to use is the Bestop method. 216 divided by 16. How many times does 16 go into 2? It doesn't. So 0, carry your 2. How many times does 16 go into 21? Goes in once, and you've got a remainder of 5. How many times does 16 go into 56? So you get 16, add another 16 is 32, add another 16 is 48, add another 16 is going to be 64, add another 16 is going to be 80, and we could continue. We're up to 56, so we can only fit in 1, 2, 3 of them. And then we've got a remainder. Okay, 56 minus 48 is a remainder of 8. So we need to extend our number. And we've got a decimal point in the answer. So we had remainder 8. How many times does 16 go into 80? 1, 2, 3, 4, 5. So your answer is 13.5 centimeters. You get 4 marks for that because it's quite tricky. There's a lot going on to do. V equals U plus AT. U equals 1, A equals minus 3, and T equals a half. Work out the value of V. So this is a substitution question, which means that anywhere you've got U, you're going to put 1 instead. Can you see U here? Anywhere you've got A, you're going to have minus 3 instead. And anywhere you've got T, you're going to have a half instead. Okay, so let's write this out and I'll show you what I mean. So the equation was V equals U plus AT. U we're going to put as 1. So let's scrub U out and put 1. A is minus 3. Okay. So for now, I'm going to put it in brackets because we're substituting it in. Minus 3. And T, which has been half rubbed out already, is going to be a half. So let's substitute that in. Remember that when 2 letters are next to each other, there's a secret hidden multiply. Now, minus 3 lots of a half. Well, when we're multiplying fractions, we can just multiply the top, multiply the bottom. Minus 3 is the same as minus 3 over 1. So that's a little trick for you. Minus 3 times 1 is minus 3. 1 times 2 is 2. Now we're plussing a minus, which is the same as just taking away. So 1 minus 3 over 2. Now 1 is the same as 2 over 2. Okay? If you've got 1 whole, then you've got 2 halves, haven't you? Yeah? You've also got 10 tenths. You've got 71 71ths, etc. But let's not confuse this. So this is the same as 2 over 2 minus 3 over 2. So you've got 2 halves, you take away 3 halves, you've got minus a half. So that's your answer for V. Question 17. 5 tins of soup have a total weight of 1,750 grams. 4 tins of soup and 3 packets of soup have a total weight of 1,490 grams. Work out the total weight of 3 tins of soup and 2 packets of soup. Now, this is actually a simultaneous equation in disguise. It's quite tricky, but let's have a go. Let's use T to mean tins of soup. And let's use P to mean packets of soup. 5 tins, 1,750. So 5 lots of T gives you 1,750 grams. So if we want 1 tin, or 1 T, divide by 5 on both sides. So we have to do 1,750 divided by 5. So it's this Bestop method again. How many times does 5 go into 1? 0. Carry your 1. How many times does 5 go into 17? Well, let's put your 5 times table up here if you're not sure. 35. Just adding 5 each time. Up to 10. And to remind yourself, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 times gives you the 15, and there's a remainder 2 because we had 17, not 15, so there's 2 left over. 5's into 25 goes 5. 5's into 0 goes 0. So T is 350 grams. Now, 4 tins of soup and 3 packets of soup have a total weight of 1,490. So as an equation, we're saying 4 lots of T plus 3 packets, so 3 lots of P, equals the weight of 1,490 grams. Now we should be able to figure out what 4 lots of T are, because 1 lot of T is 350, sorry. 4 times 350, well, I've told you a trick for times by 4. Times by 2 is a trick. So 350 times 2 is 700, times 2 again, 1,400. 1,400 plus 3p, 3 lots of p, equals 1,490. Now let's take off the 1,400 from both sides. That's gone from here now, so you've just got 3p left, and take it off from here, 90 left. We want p on its own. We've got 3 times p, so we're going to divide both sides of the equation by 3. Gives us p on this side. 90 over 3 is 30. So 1p is 30. So we've done this bit. We've done this bit. Now the final answer is going to be the total weight for 3 tins of soup and 2 packets of soup. So 3 tins plus 2 packets of soup. 2 times p is the answer that the examiners want. So 3 times t was 350 and p was 30. So we want to add these two numbers. So 2 times 30 gives you 60. 3 times 350, well, let's do it like this. 0, 15, 9, add your 1, 1050. Add on 60, gives you 1, 1, 1, 0. And it's already got the grams for you. Okay? Moving on. Question 18. Bellina has a garden in the shape of a circle of radius 10 meters. What a strange garden. He is going to cover the garden with grass seed to make a lawn. Grass seed is sold in boxes. Each box of grass seed will cover 46 meters squared of garden. Bellina wants to cover all of the garden with grass seed. Work out an estimate for the number of boxes of grass seed Bellina needs. You must show your working. Right, it's saying estimate, so we don't have to be perfect here. Now, he's got a strange shaped garden, I'm not going to lie. It's in the shape of a circle. I don't know about you, but I've never seen a garden in the shape of a circle. But that's what the examiners want, so that's what they're going to get. We want to know the area, how much grass is in this circle. Okay, so what we want to do for area of a circle is know the formula. The formula is pi times r squared, or pi r squared, where r is the radius. Now the radius is halfway across and it's 10 meters. So r squared is 10 times 10, which is 100 meters squared. Pi is on your calculator and it's stored as about 3.14. Now it's just an estimate, so we can use 3.14 instead of being more exact. Timesing it by 100 gives us 314, and the units is meters squared. Now, Bellina wants to cover all the grass, and each box has 46 meters squared in. So it's another divide. We're saying how many boxes, how many times does 46 go into 314? So bus stop method again. There is another way apart from bus stop method that will be quicker here, so I'll show you that instead. Okay, all we do is we keep adding 46 onto itself until we get over this. So 46 add 46 is going to be 92. So it goes 46, 92, add another 46, 138, add another 46 is going to give you 184, add another 46 is going to give you 230. Okay, add another 46, 276, add another 46 is going to give you 2 carry 1, add on 40, carry 1, 322. So we've gone over. So once we've got this many boxes, we've got enough. And each time we were adding 46. You might want to do a bit more working to get to this answer. I was just trying to do it quick to show you the method. So 7 boxes takes us over, so 7 boxes is enough. Don't go for 6 because you've not got enough then. 7 boxes. B. Is your estimate for part A an underestimate or an overestimate? Give a reason for your answer. If you look at pi on your calculator, then you would see that it's something like 3.141529, something like that. Okay. Now we've actually called it 3.14. So really, we're a bit less because we've done 3.140000. So it's an underestimate of area since used 3.14 for pi. Pi is spelt P-I, not P-I-E, the food. Okay. Now the reason I don't like it is even if we did use 3.141, 7 boxes would still be enough. Okay, but the examiner's trying to get you to see that you might have done an estimate. And we could have even used 3 for pi, which would have made it even more of an underestimate. Okay. Anyway, let's leave that one there. I don't want to confuse things too much. Question 19. Solve 4 brackets x minus 5 equals 18. Now, if you've got a 4 in a bracket, that actually means you've got a little multiply between. Okay, so we're going to do a little trick and undo this. So we're going to divide it by 4, divide it by 4. Okay, to get rid of this times 4. So when we've done that, we've just got the x minus 5 left. Now 18 over 4. To divide by 4, we can divide by 2, divide by 2. Just like when you times by 4, you can times 2 times 2. So 18 divided by 2 is 9. Half of 9 is 4.5. Okay. Now, we don't need the brackets anymore, you'll be glad to know, because there's nothing multiplying it. You've just got x minus 5 on its own. So now we want x on its own, so we want to get rid of this minus 5, which we do by adding 5. You have to do the same to both sides. So x equals 9.5 as your answer. Next question. Minus 3 is less than t, which is less than or equal to 2. T is an integer. An integer just means a whole number. So think of your number line. 0 in the middle. Going up. 1, 2, 3. Start that again. You're going up. 1, 2, 3, etc. Like you've learnt to count your whole life. Going down, we're going backwards. Minus 1, minus 2, minus 3, minus 4. Now we want numbers that are less than or equal to 2. So we want 2, we want 1, we want 0, we want minus 1, we want minus 2, but we do not want to include minus 3 because we want it greater than minus 3 but not equal to it. Okay, so the range that we're talking about is here. We do include this guy at the end, but we don't include this because we don't have the extra equal sign as well. So your answer's minus 2, minus 1, 0, 1, and 2. Question 20. Asmal is paid £1,500 per month. He is going to get a 3% increase in the amount of money he is paid. Work out how much money Asmal will be paid per month after the increase. There's different ways to do this. I'll show you a way without the calculator because we don't have a calculator. 1,500. Now 1% is the same as dividing that by 100. So to divide by 100, move the number, or equivalently move decimal place, shift the number along twice. Okay, so it was 150000. Let's do it over here so you can see clearly what's going on. 1500 00. Now we're shifting it, making it smaller. 1 2. £15 is 1%. He's got a 3% increase, so times that by 3. 15, 30, 45 is your 15 times table. So he's got a £45 increase, and he still gets the money he was getting before. They're not going to take that off him. So you add it on. 1,545. Lucky Asmol. Moving on. Question 21. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. Okay, so maximum temperature is at the side, and number of hours of sunshine is along the bottom. One of the points is an outlier. Write down the coordinates of this point. Now when you're writing coordinates, remember to go along the corridor before you go up the stairs. That's the saying to remember it. Okay, and another way to remember it is x, y, and x comes before y in the alphabet. Whatever works for you. Now we need to know what the outlier is. Now an outlier is something that doesn't fit in with the rest of the data. Can you see where all the data is over here? And there's one guy that doesn't fit in with that. Okay, so we need to write down the coordinates of this point. This is the outlier. Okay, so the coordinates, let's read down, and it's between 9 and 11, so that's 10. Read across, it's between 18 and 20, so that's 19. So across and then up, so it's 10, 19 is your answer. Part B, for all the other points, write down a type of correlation. So these guys that we've highlighted in yellow, what is their correlation? Now we're going to the right and up, and this type of correlation is called positive, because they're both going up together. Okay, if one was going down and the other one up, then that would be negative. So remember, if your arrow is going this way, positive. If it's going this way, negative. So it's positive correlation. Moving on. On the same day, in another British town, the maximum temperature was 16.4 degrees C. Estimate the number of hours of sunshine in this town on this day. So let's go back to our graph. 16.4 degrees C is the maximum temperature, and maximum temperature is at the side. So we need to mark on 16.4. So it's 5 squares to go up, so each one is 0.2. So 16.4 is 2 up. Okay, and we know it's going to be with the rest of the guys in yellow. So we're going to be going across to the yellow line and then down. Now what you might actually do instead of a highlighter in your exam is a line of best fit, which is going to be a straight line through all the points to try and get all the points in the middle. It's going to be something like that. Okay, still giving you the same answer of 13. So let's write that down. A weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. So temperatures are higher when there is more sunshine. Does that sound sensible? Well, when do you have more hours of sunshine? It's usually in the summer. Okay, and what's the temperature like in the summer? It's usually hot. So in our heads this makes sense, but does it make sense with the scatter graph? Okay, so let's look back at the scatter graph. So higher number of hours of sunshine, higher temperatures, these guys. So yes, he's right. Okay. Yes, higher temperatures happen on days with more hours of sunshine. Okay, moving on. Question 22. Express 56 as the product of its prime factors. This is actually quite fun to do, I think. It helps if you know your times tables, because what we're going to do is we want to split 56 up into two numbers that multiply together to give 56. Now, if it's an even number, you can always take out 2. So let's stick to that if we didn't know our times tables of 56 in. There is one, you might be shouting at the screen at home. But both ways will get the same answer. 2 times what gives you 56? Well, 25 times 2 is 50. So 28 times 2 gives you 56. Going to put the 2 in a square because you can't split 2 up anymore because you're not allowed to use 1. Okay, because that's cheating. You can't say, well, 1 times 2 is 2 because then you're using 2 again. It has to be different numbers. Okay, remember that. Different numbers. So 28 is even again. So let's go take 2 out, and it's going to be 14 with it. Okay. And 14 is even again. So you can take 2 out again, and this time you take 7. Can you split up 7 without using 1? The answer is no. And the reason is because those ones in the square are primes. Okay? They're factors of 56 and they're primes. So they're prime factors. So we've got 2 times 2 times 2 times 7 gives you 56. And if you want to really show off, 2 times 2 times 2 can be written as 2 cubed times by 7. That's your answer. Moving on. Question 23. Work out 54.6 times by 4.3. There are so many different ways to multiply numbers, okay, and I can only choose one method to show you. The method that we're going to do today, let me think. Let's do the one called the Chinese lattice method. So we write out our number, 54.6 across and 4.3 going down. And now we need to draw out a nice neat grid. So a nice neat grid, 3 by 2, because it's 3 digit by 2 digit. And now for Chinese lattice method, we actually want to go across, diagonal through these, okay, like so. If you've not seen this before, this will be looking very confusing to you, but see if you like the method. Okay, what the method says is for each square you just multiply the two numbers that go into it, and at the top you put your tens and the bottom you put your units. Okay, so you'll see what I mean when we get started. 6 times 4 is 24, so 24. 6 times 3 is 18, so 1, 8. 4 times 4 is 16, 1, 6. 5 times 4 is 20, 2, 0. 4 times 3 is 12, 1, 2. 5 times 3 is 15. That's all the multiplying you need to do with this method. So it's very cool. Now, can you see that we're divided up into lines like this? What we're going to do now is add along those lines. So first one is just 8 on its own. So that's your answer. The next one, we've got more to add up. 4 add 1 add 2, and that gives you 7. The next one, 2 add 6 is 8, add 1 is 9, add 5 is 14, so you put your 4 there, carry your 1. 1 add 1 is 2, plus you've got your 1 here, 3, and 2 on its own there. So this number is going to come out as our answer. But this question is even more tricky because we've got decimal places too. Now with the decimals, go down until they meet and then follow the diagonal through. So it goes here. So your final answer is 234.78 for 3 marks. It's a really nice method to learn. And if everyone wants, I can make a video teaching that method if we get some requests. Question 24. The area of the square ABCD is 10 centimeters squared. So let's show what we're talking about. This whole area is 10 centimeters squared. Okay. Yeah. 10 centimeters squared. Show that x squared plus 6x is 1. What a strange question. So, what do you know about squares? You know that you do the base times the height. Okay. So this times this, and they're going to be the same. So what is this? It's 3 plus x. We're going to times it by itself. Now because we're going to times it by itself, we write it next to each other and we need brackets to keep it together. Okay? That gives you the area, and we know the area is 10. So now we need to multiply these brackets out. Okay, you can use the boomerang or a smiley face. I use the boomerang or half moon. Okay, so 3 times 3 is 9. 3 times x is 3x. They're both pluses. Now going below. X times 3 is 3x as well. And x times x is x squared. Now we can combine our x's together. 3x add 3x gives you 6x. So that means we've got 9 add 6x add x squared gives you 10. And we're getting close to what they want us to find out. All we need to do is take off the 9 from both sides to get 6x plus x squared is 1, and then just rearrange it, swap these guys around. X squared plus 6x equals 1. Shown it. When you get to show that question, it's quite nice because you know if you've got the marks. That's 3 marks in the bag. Question 25. The rectangular frame is made from 5 straight pieces of metal. 1, 2, 3, 4, 5. The weight of the metal is 1.5 kilogram per meter. Work out the total weight of the metal in the frame. I'll show you the ones that are easy to find. This one, 12. This one, 5. And by the fact that they're the same, we now know this top one and the side one. Okay? Just show you that again. So this is 5 down the side, which means that this is also 5. 5 meters. Same with the 12. This is 12 here, which means that this is 12 here as well. Okay. So, let's add up those so far. 5 add 5 is 10. And 12 add 12 is 24. So put them together, you get 34. So we've done this one, we've done this one, done this one, done this one. The hardest one to do, let me tell you now, is this diagonal. And we're going to need something called Pythagoras to figure this one out. So let's take this triangle to one side, which we'll do. Not very neat at all. This is shocking. So sorry about that. There you go. That's your triangle. Okay? So take this triangle to one side. We can do a bit of work on it. So it's right angle, 12 by 5. Pythagoras' theorem says that if we want to know what this is, then we can square that, add them together and square root them. Okay? So square it, add square root. So 12 squared is 144. 5 squared, 5 times 5 is 25. Add them together, you get 169. And we want the square root of 169. That means what times what gives you 169? And the answer is 13. Okay, so this is 13. Now, add that to the other lengths. So the total length is is going to be 34 plus 13, which gives you 47 meters. Now let's look back at the question. The weight of a metal is 1.5 kilogram for every meter. Okay, so times by 1.5. That means just times by 1.5. Half of 47 divided by 2, you get 23.5. Add them together, you get 70.5. So your answer is 70.5 kilograms. And you get 5 marks for that. Question 26. The equation of line L1 is y equals 3x minus 2. The equation of line L2 is 3y minus 9x add 5 is 0. Show that these two lines are parallel. Now there's a nice way to write lines, and that is y equals mx plus c. So it's y equals some number times by x, add another number. This is called our gradient, which tells you how steep the line is. And this is called our intercept, or y-intercept, where it crosses the axis. Okay, so just to give you a very quick lesson, straight lines come in all different forms. So it could be like this, like this, like this. Gradient is telling you how steep they are. And the y-intercept is telling you where they cross here. Anyway, let's get back to business. So we want to write them in this form, y equals. First one is already fine. It's the second one I'm worried about. 3y minus 9x plus 5 equals 0. So, we want y on its own. So let's divide everything by 3. So, y minus 3x plus 5 over 3, we don't have to actually figure it out, equals 0. Nothing divided by 3 is nothing. If you say to your mates, I've got no money, let's share it out, how much are you going to get each? Nothing. Okay, let's take this stuff to the other side. So, reverse the sign, 3x minus 5 over 3. So now we've got it in the form of y equals mx plus c. Okay, so gradients both equal 3, therefore parallel. Job done. Moving on to the final question. Question 27. A, B, C, D is a parallelogram. The diagonals of the parallelogram intercept at O. O to A, let's draw these on. O to A is the vector A, and O to B is the vector B. Okay. Find in terms of B the vector DB. So we want D to B all that way. Now, what we know is because this is a parallelogram, that actually these lengths are the same. So this and this are the same because they're just cut in half. Okay, so this is B as well. So to go from here to here, it's 2 lots of B. and you can underline to show it's a vector. I do have a separate video on vectors if you want to check that out. Find in terms of A and B the vector A to B. So we want to go from A to B, but knowing stuff that we know. So we want to go along here and then up here. Now if we're going backwards through A, then it's minus A. And then we're going forwards through B, so it's plus B. Part C. In terms of A and B, the vector A to D. So now we want to go from here to here. So we go A to B, we already know how to do that. Minus A plus B. And back along here is minus 2B. So it's minus A plus B minus 2B, which gives you minus A minus B. And that's the end. Total marks for this paper is 80, and hopefully we've just got 80 out of 80. Thanks for watching, guys. I've been out of practice for a while with these videos. Let me know if you have any comments or anything that you want to see, and I will see what I can do for you. Good luck in your studies and your revision, and I hope that you achieve maths. I've also written a book about how to achieve in maths, so if you want to check that out, then you'll follow the link below this video. Thanks for watching.